Okay, so this is our video on 4.3. We've already done 4.1 to 4.2, and we're on page 215, numbers 3 to 6, 8 to 36, every other even. Just as a quick reminder, write what I write, especially on the first few, the whole sentences. So the first one is, if it's odd degree, you have at least one real zero. So if it was Math Excel, 1 would be the blank, but write the whole sentence. If you have a degree 5 function with 3 plus 4i, another one would be 3 minus 4i. So notice the plus sign here and then the minus sign here. It's not negative 3 plus 4i. In other words, that number doesn't change sign. The I term does change sign. Then number 5, a polynomial has at most, which means max, n real zeros. That's true. Number 6, if you have a degree 4 function, you could have zeros, negative 3, 2 plus I, 2 minus I, and negative 3 plus I. True or false? That's false, because this one needs the other pair. Remember, we call that a conjugate pair. So you would also need this, which would then change it to a 5th degree. And then you have a couple of easy ones as far as list the remaining zeros. This one's degree 3, and they tell you 4 and 3 plus I, so then you put 3 minus I. And then this one is degree 5 with 0, 1, 2, and I, so then you put negative I. This one's degree 6 with zeros I, 3 minus 2I, negative 2 plus I. And so then you just change this to be negative I, 3 plus 2I, and negative 2 minus I. Any questions on those? Okay. As a reminder, Math Excel is available. Okay. So now moving on to number 20. This is the first one you have to expand. So our goal is, if it's 4th or 5th degree, expand all. And if it's 6th degree, then do what I do. So those are just instructions. Okay, so on this one, what we have is degree 6, and we have zeros that are I, 4 minus I, and 2 plus I. So that's what the problem looks like. We have degree 6 with zeros I, 4 minus I, and 2 plus I. So that means it would also be negative I, 4 plus I, and 2 minus I. So that part is just the same as like the previous instructions, but now we've got to show our factorization. Show factorization and expansion. Show the factorization and the expansion. So we have f of x equals a, which we're going to assume is 1 on the very next step. And then we take each of the terms, and I'm going to put 2 terms in a row, like the I and the negative I terms, like back to back, for it to make sense. And it's also going to be easier to expand that way. So I'm going to have x minus I, x plus I. So that's 2 of them. And then you have your 4 minus I. So we're going to have x minus parentheses 4 minus I. So it's always x minus whatever the root was. And then we need x minus 4 plus I. And we also need the x minus 2 plus I and the x minus 2 minus I. Okay, so there's that line. I'm going to go ahead and start taking two at a time, like those two at a time, and then this one, these I need to distribute. So I'm using FOIL. I'm doing x times x is x squared. X times I is ix, and then minus ix cancels. So I'm not going to write that. Then negative I times I is negative I squared. And then I'll distribute the negative 1 to all of these. So then this would be x minus 4 plus I, x minus 4 minus I, x minus 2 minus I, x minus 2 plus I. Okay, so recall from yesterday and maybe last year, I squared is negative 1. And so this is going to change to x squared minus negative 1, so it's x squared plus 1. So make sure you see that if it's negative I squared, that means minus a negative 1, which is why we have plus 1. Any questions so far? Okay. Then we're going to distribute the x to everything, and then the negative 4 to everything, like within this group of 2, and then the I to everything. So this would be x squared minus 4x minus ix and then the negative 4 to everything, so negative 4 times x, negative 4 times negative 4 is positive 16, and negative 4 times negative I is plus 4i. Okay, and then we need to do I times each of those. So I times x is ix. I times negative 4 is negative 4i. I times negative I is negative I squared. Okay. And then we'll have to do the other one also, but for right now I don't have room for it. I'm just going to say the right side. This is what I consider the right side, because I don't have room. Probably should have started more to the left. But this is what our goal is, to start canceling things. That's how you actually know you did it right. I'm going to change colors. Negative ix and ix cancel, and 4i and negative 4i cancel. And then we also have some like terms we can combine. So we have x squared plus 1, and then x squared. Negative 4x minus another 4x is negative 8x. And then 16 minus a negative 1 is 16 plus 1, so that gives you 17. So all of that expanded to x squared minus 8x plus 17. Now we need to do the same thing to these terms, the x minus 2 minus I and the x minus 2 plus I. Before I start doing that, I want to make sure y'all are caught up. Yes?
On the step where it has like a 1 as a one coefficient,
Oh, yeah.
like how do we get rid of the parentheses around the 4 minus I and the 4 plus I? Like, only have to distribute the x to...
Oh, okay. So that's a good question. When you're multiplying, you just have to multiply it to one term, not to every single thing, because that would change your result. I think you're saying, like, why didn't we do x to this one also? We can only take two at a time. Is that what you're asking, or am I?
Well, like, in the step before, there's parentheses around the 4 minus I. Oh, never mind. Oh, okay.
Yeah, we just have to take two at a time. So these two changed into this, and then these two changed into this eventually. And now I'm about to work on these two. I guess the difference is, like, if you were normally distributing, it'd be just like 3 times x plus 1 is 3x plus 3. But the problem is, on this, we've got so much more multiplication that it is more complicated. But you still just do two at a time. Okay. All right, so now let's distribute the -1 for this. So this would be x minus 2 minus I, x minus 2 plus I. I'm going to keep my left side the same. And now start expanding this thing. So x times x is x squared. X times -2 is -2x. X times I is ix. I try to put the variable last, meaning like the x variable. I like putting the I in front of it. But xi and ix are really the same thing. So that's distributing the x. Now I need to distribute the -2. So -2 times x is -2x. -2 times -2 is +4. -2 times I is -2i. Then -I times x is -ix. That's going to end up canceling with this ix. Is it okay if I don't write it and I just cross this one out? Is that okay with you guys? Okay. Okay, so this one canceled out. -2 times I is +2i, which cancels out with this one, because -2i and +2i cancel out. And then -I times I is -I squared. So again, if you do it right, two things should cancel, plus you're going to have some like terms. Okay, so this is a 6th degree. That's why this is such a long problem. We're going to bring down these things, x squared plus 1, x squared minus 8x plus 17. And we'll combine our like terms on here, which would be -2x minus 2x is minus 4x, and 4 minus -1 is +5. So at this point I'm stopping since it's 6th degree. Because I don't want to keep on going forever on the same problem. But the key has x to the 6th minus 12x to the 5th plus 55x to the 4th minus 120x cubed plus 139x squared minus 108x plus 85. And so I don't expect y'all to go all the way from here to there since it's 6 degrees, because that's just way too much. Yes?
On like the very end, like what we just did.
This one?
Yeah, whenever you got a positive 5, how'd you get a positive 5 if it's a positive 4 minus 1?
Oh, okay. So it goes back to this. That's a good question. So we have minus I squared. Well, I squared is negative 1, and we're doing minus a negative 1.
Okay.
So then that turns into plus 1. Yeah, good question. Yeah, so if it were 4th or 5th degree, we'd have to keep going because basically you'd cover up this, and then you'd have to distribute the x squared and distribute the 1, then combine your like terms. But it's just too much for this one. Okay. Any questions about that? Okay. I think y'all are done writing that almost. Okay. So now after 20, we're doing every other even, so that'd be 24. And this is a shorter problem. 20 was probably the longest. So 24, f of x is x cubed plus 3x squared plus 25x plus 75. And it tells you you have a 0 of negative 5i. So you have x cubed plus 3x squared plus 25x plus 75, and your 0 is negative 5i. So we know that from our theorem that if there's one, there has to be one real root since it's odd. This is just a little side note. If you don't want to write that, you don't have to. Use the calculator. Whoops, that slid. Okay, must have one real root since it's odd, and use the calculator. So, just like what we do on the other one, the previous lesson, we go to New Document, Add Graph, and then we go x up arrow 3 plus 3x squared plus 25x plus 75. Enter. Okay, so in this case, looks like we got lucky. It's an integer. I can check in the table and get it as negative 3. Or this is the way that it would always work. You can go to your analyze graph, go to 0, and go from here to here, because sometimes it's not at the integer, and then you just move it by doing this. Push down and then move it. And drop it. So negative 3, 0. So the root from the calculator is negative 3, 0. And then because this is negative 5i, then we need to say the other one is 5i. So then your solution has the little curly braces, and you'd have negative 3 and then plus and minus 5i. Now, if MathExcel doesn't like that for some reason, then put it as negative 3, comma 5i, comma negative 5i. But I think it should accept that. But if you had a number plus or minus, then it may not. So just experiment with that on your own. but we're going to want that. Any questions? Okay, so that's 24. 28. This one we have f of x equal x to the fourth minus 7x cubed plus 14x squared minus 38x minus 60. And you're given that there's a 0 at 1 plus 3i. X to the fourth minus 7x cubed plus 14x squared minus 38x minus 60, and a 0 at 1 plus 3i. So this one has fourth degree, and we have one of the I terms, so the other one we know should be 1 minus 3i, and so now we have 2 out of 4. So we should have 2 real to make 4. Okay, so then at that point we use the calculator. Add graph, x up arrow 4, minus 7x up arrow 3, plus 14x squared minus 38x minus 60. Okay, check it. X to the fourth minus 7x cubed plus 14x squared minus 38x minus 60. Okay, so then let's get our roots. So between here and here, negative 1, 0, and between here and here is 6, 0. So it's going to have negative 1, 6, and then 1 plus or minus 3i. Again, if it doesn't like it, then negative 1, 6, 1 minus 3i, 1 plus 3i. And it doesn't matter the order. Any questions? Okay, 32. This one we have x to the fourth minus 1. So believe it or not, this is called the difference of two squares, even though it's x to the fourth, because you can think of x squared squared minus 1. So we need to break this down into x squared minus 1, x squared plus 1. And then the left side can be broken down into the difference of two squares also. So I have x minus 1, x plus 1, and then I have my x squared plus 1. Any questions at that point?
That's about it.
Yeah. Freeze this for a minute. Okay, so then you know there's real answers at 1 and negative 1. And then you want to set this other one equal to 0. So you have x squared plus 1 equal to 0. X squared is negative 1. and we know I squared is negative 1. So that means that like if we take our square root of this one, we're going to get x equal plus and minus the square root of negative 1. So that's plus and minus I. So basically our solutions are going to be plus and minus 1 and plus and minus I. Or you could list all four out. 1, negative 1, I, negative I. Move that up a little bit. Any questions about that? No, good. Okay. The last one for the lesson, because this is one of your shorter lessons, number 36. Okay, so on 36, this is our last one. We have x to the fourth plus 13x squared plus 36. So I don't know if you were taught about use substitution last year, but just as a reminder, you could use substitution and say u equal x squared. That way it would look like u squared plus 13u plus 36. If not, that's okay. If you'd rather just keep it x to the fourth, so just pick and choose whichever way you want to do it. So if I use substitution, then my goal is to get 36 and do that by multiplying, but to get 13 by adding. Now I'm doing a couple of these off the top of my head, but you could do 36 divided by x and use the table. So I know it may look weird to you because you're now changing from a polynomial to a rational function, but for those that like shortcuts, this is for you. So you could do add graph and do 36 divided by x. Now I know it's a rational graph. I don't really care about the graph. I care about the table. So it's 1 times 36, 2 times 18, 3 times 12, 4 times 9, and so forth. Now, if I were making a list, I would not use 5 times 7.2 because that's not a whole number. So don't use 5 times 7.2. But out of these choices, if we're trying to add and get 13, it's got to be this one, because there we get 37, 20, and 15. So that's going to be a good indication of what you need. So we're going to have u plus 4 and u plus 9. U plus 4 and u plus 9. And we can set that equal to 0. So u is negative 4 and u is negative 9. At that point, if you want to shortcut it a little bit, you can. I'm going to write it all out. So I have x squared equal negative 4. So x is going to be plus and minus the square root of negative 4, which is plus and minus 2i. On this one, I'm just going to say plus and minus 3i, because that's how it works. If you want to jump directly to this and that, that's fine. So it's a little bit about u substitution there. So our solution would be plus and minus 2i and plus and minus 3i. Now, if you didn't want to use u substitution, you could have just factored x squared plus 4, x squared plus 9, and then said that's plus and minus 2i, and this is plus and minus 3i. So when you get really good at this, you can do it this way with a lot fewer steps. But that's completely up to you. Okay, that'll be the end of the lesson and the video. Now you could work on your Math Excel.